We'll talk today about the importance of code-to-runtime software inventory. No one talks about this when they build their AppSec program. So we'll talk about 4 things. If we'll have time, we'll go through a demo. We'll talk about the obvious thing of you can't secure what you don't know or can't see. And we will see the outcome of that. We'll talk about how using a deep code analysis technology, something that we developed in Apiro, can help us build a software inventory. We'll talk a little bit about what does it mean application risk, because everyone thinks it's CVSS core or APSS. No, it's not. And then we will ask 9 questions that will help us build a risk-based software inventory. So I know we don't have a lot of people in the audience, but I have 3 questions, and I want if you can raise your hand and tell me if you can answer these 3 questions today in your environment. Number 1, which and how many code repos contains high business impact crown jewels application? Can you answer that today? And do you know that it's changing every day? Because tomorrow I can add PII. It's based on self-attestation questionnaires. Okay? Second question, how many GenAI framework usage in your code, okay, that expose PII via an exit point, for example, to OpenAI, were added in your code base in the last month that didn't go through a security review or an SCA scan? Can you answer that? Anyone else? Can you answer that? Okay. And the last question is, how many Java APIs I have in my code base that expose PII without authorization and didn't go through a pen test? So these are just examples of questions. And let's say we have an answer today. Tomorrow, the answer can be totally different because your code base is like a living and breathing organism that changes every day. So how a real-time code-to-runtime inventory can help you? 1 is automatically focus on the most risky applications because AppSec is a very small team and you have a lot of engineers. We have customers with 17,000 software engineers and only 100 people on the AppSec team. You can proactively trigger security reviews without the manual self-attestation questionnaires and prioritize vulnerabilities based on risk to the business, based on your software architecture and environmental factors. And lastly, you can proactively trigger with a real-time code inventory and software inventory. You can actually trigger a pen test without wasting time of your developers and also your pen test while scoping the application and asking them tedious questions that are changing every day. So I think I've met more than 500 customers in the last 4 years talking about their application security program. And guess what? None of them starts with an inventory. Everyone starts with, I want tools. I want the new shiny tool with a new feature. And then what happened? You get a cacophony of so many tools and processes and so many vulnerabilities. And now you have another problem. You need to prioritize them. But why do you get to this point? Build an accurate inventory. Understand where are your crown jewels. Where do you need to enable your scanning tools and manual testing tools? And then be more efficient and effective. This is what makes your AppSec program failed, because you want too many tools and too many processes. This is a real example from one of our largest customers. As you can see, they have 120,000 code repos. Okay? They have 7,000 developers. In 1 minute, we can tell them only 56% contain sensitive APIs in your code base. Only 23% contains PII data in the data fields. only 8% were automatically classified by our deep code analysis technology that I will talk about in a second as high business impact applications. Only 5% has high or critical risks in them. Only 4% are deployed, 1% exposed to the internet, and less than 1% are user-facing applications. So I think in 10 seconds, we prioritized more than 99% of our repos to focus when we do security review, pen test, scanning of using our AST tools. And we're transforming our application security program to be much more effective and efficient. Everyone are talking about SBOM. SBOM, 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 why? Let's understand why, and let's understand if it can be your software inventory. So first, you have the executive order, and you have the NIST framework, and you have compliance requirements from different other frameworks, and you have the open source framework like CycloneDX and Salsa and others. And there is tons of buzz from 2017 to this year. But what is an SBOM? So if you ask your SCA tool, it's a list, just a list, flat list of all your open source dependency and your transitive dependencies. What are the versions, licenses, and maybe vulnerabilities in some cases. But if you ask your IIC tool, for example, or any other tools, you get a different answer. It's your IIC components and artifact locations and vulnerabilities. And what about all the other components that assemble your application? No one talks about them. And in a second, we will go a little bit deeper. But before that, if we read the executive order, it's explicitly saying that you need to maintain an up-to-date inventory of your software code, like your internal proprietary code, but also open source code, not only open source dependencies, this is what SBOM means, all your open source dependencies, and tools and processes. And when we look at the structure of CycloneDX or the SBOM format, we don't see all the things that the executive order is telling us. So what we are missing in SBOM, I took just a few, let's say, nodes on the graph, okay? Code module. Code module is a logical representation of your software, why it's not there. Maybe you have a code module that transfers money versus code module that is a test code. I need to know that. It's part of my software architecture. Frameworks, data access objects, data models that store data, APIs in my code, PII data in my code base, serverless functions, secrets, security controls like authentication, authorization, encryption, and what about my source control manager security posture and CI/CD posture? These are all missing from the standard SBOM classification. So we are introducing an extended SBOM. An extended SBOM is actually a representation of your software architecture. What we do, we connect to your source control manager via API and to other data sources. And we scan the code throughout the history. And we map all your open source dependencies, all your APIs in your code, all your database frameworks, all your GenAI usage or frameworks dependencies, all your secrets, all your developers' knowledge, because a developer, I didn't put it in the previous slide, but a developer might introduce a risk to your software. And we connect it on a graph. And then we say a data model is connected to this API. And all these code components are related to the same code module that is responsible for money transfer in your application. And this code module is connected to your code repo, which is connected to your CI/CD pipeline. And this is the map that we're building from scanning your code. This is the patent technology that we've built in the last 4.5 years, which called deep code analysis, that maps everything and track the changes of every code commit that you push to your feature branch, main branch, or pull request. So let's say I added a new API, it will be updated. We will update the inventory automatically. If I change a logic of an API or a database or GenAI framework, it will be classified as material changes and trigger a security process. Now, the next thing that we're doing is doing a matching between code to runtime. So now we know exactly that this RESTful API in your code is actually run in this Kubernetes cluster and exposed to the internet through your WAF or whatever. So it's not only connecting to your source control manager, we also connect to your runtime environment and do the matching so your software inventory will be accurate and contextual with, like, contextualizing every code component that we detect. So what the SBOM, the XBOM, the extended SBOM includes? We, let's call it 2 buckets. Bucket number 1 is your software architecture or your software components. And I will not go over all the list. But on the other bucket, we also have all the tools and all the processes. So now on the graph, we can ask complex questions and say, okay, this API was scanned by this tool, was deployed by this pipeline at this time, and did or went through this pen test. So anything that assembled your application is actually in the XBOM. Next, we need to assess risk. So we understand that software is a graph. Now we need to augment the risks on top of the graph, because I can have log4j with CVSS score 10, but it's low risk in my business. In my application, it's low risk. So what we're doing, same graph that you saw earlier, we just augment the risk on top of them. So we detected the API in the code, and we ingested the SAST finding, and we did matching between your SQL injection to the RESTful API in the code. Now we do the same thing for your log4j and for the developer, because we profile the behavior of the developers and the activity throughout the history. And then we scan the CI/CD configuration and find misconfigured CI/CD or a vulnerability. And then we take the secret and we validate the secret against the service. Is it valid in Google, for example, or AWS? And then we connect again the dots and we say, this data model, which is a legit data model, has PII data that is exposed by this API. And then everything is connected to the same high business impact code module, which uses OpenAI framework with RCE. This code module is connected to the repo and to the pipeline and to all the way to runtime. So now it's not a single alert, which is a vulnerability. It's actually a toxic combination of multiple alerts that is augmented on my software architecture. And now I can actually prioritize and understand the risk based on this real-time software inventory. Next, what we're doing is we calculate the risk based on likelihood and impact factors, and I will give a few examples. Is this open source dependencies actually reachable in my code? Is it being used in my applicative code? Maybe it's only declared in the POM XML. So the likelihood is higher if it's used in my application code and is reachable. Is it deployed, internet exposed? Is it has, a known exploit or POC? And on the impact side, we automatically correlate these toxic combinations. We say this API exposes sensitive data, but it also uses an open source package with a risk. And then we know how many of these types of risks are deployed across multiple code modules, which is, you know, a blast radius across my software architecture. And lastly, we know if this is a high business impact application or not based on our deep code analysis technology, or you can ingest it from your own risk management tools. This is being done manually today before releasing code to production. All these things are being done in the large enterprises that we knew before using Apiro. They use that analysis with questionnaires and manual reviews, and it's a blocker to any software velocity. So very quickly, again, it's a complex graph, but this is what we have built behind the scenes, okay? So it's more than 50 entities, more than 100 relationships, edges, and more than 10 million nodes on a customer environment. And this is what we're doing by scanning your code and enriching it from different sources. I have 9 questions that we compiled from working with, I want to say, Fortune 500 and even Fortune 10 customers. We break it down into three buckets. First, visibility and risk assessment. Second, risk-based prioritization. And third, remediation, prevention, and measurements. So first question is what exists in my repos and pipelines, which is the extended SBOM that I presented. The second thing is what is the coverage of my application processes and tools? Is this crown jewel repo is scanned by an SCA and SAST and pen test before release to the cloud or not? And lastly, what is the risk posture, the overall risk posture and score of this repo or multiple repos that assemble an application? On the prioritization side, when we have this data, now we can, you saw the funnel or the prioritization funnel, now we can focus on the highest risks applications based on our factors. Then we can see which vulnerabilities are reachable in the code. It's a factor for prioritization. And lastly, what are the riskiest changes? Because everyone talks about vulnerabilities, but if I change my database from Mongo to SQL, now my attack surface changed significantly. And it's not a TVE, so I need to know that without a manual process. So we detect that as a material change, for example, when we implement Apiro at these large enterprises. Then, to be able to remediate and prevent and measure, I need to know who is the code owner. It's a huge problem when you have above 500 developers. Then, when should a security process be triggered? Based on these changes, based on this risk analysis that we did. And lastly, can I measure my MTTR versus SLA before releasing to the cloud? Do we have more time? So that's it. This is the importance of building an accurate real-time code-to-runtime software inventory is so important to assess the risk of our code changes because they are growing exponentially. And without knowing what we have, we can't secure it. Thank you very much. And if you have any questions, you can come to our booth. Thank you.